Do you ever think that someone like us would also prevail in another world? Or is the life that we've been observing on Earth for thousands of years found in any corner of this universe? You think it or not, however, scientists have been speculating and trying to find it in the universe for miscellaneous years. Recently, he got the signs of life through James Webb Telescope on the Earth-like world Exoplanet Proxima B. An exoplanet is a planet outside the solar system. The first exoplanet was noticed in 1917, but its recognition was not confirmed. Then, it was confirmed in 1992, and the second exoplanet was observed in 1988 and confirmed in 2003. Until now, there are approximately 5,125 exoplanets that have been confirmed. Exoplanet Proxima Centauri B, or Proxima B, is orbiting in the habitable zone of the red dwarf star Proxima Centauri, which is the nearest star to the Sun and part of the triple star system Alpha Centauri. The distance between us and that planet is 4.2 light-years. It is an Earth-like planet that encloses our neighboring solar system. The triple star system encompasses 3 stars, Alpha Centauri A, B, and C, which is also called Proxima Centauri. The astonishing thing about this planet is that it has a locked zone area that is not too hot or too cold, which means it has a highly favorable atmosphere for liquid water. Moreover, presuming that life in any form may probably survive in Proxima B because life on Earth arose similarly in the water. There are a lot of circumstances and facts about this red dwarf planet that make it an Earth-like planet. These circumstances relate to the Earth, especially when life was initiated on our planet. The more incredible thing about Proxima Centauri is that it is the nearest star to Earth, just 4 light-years away. The existence of life on any planet depends on its weather condition and atmosphere. The orbit of Proxima B is 20 times closer to its star than the Earth's orbit to the Sun. It comes across that life on Proxima B is severe, but a fascinating fact is that it takes almost the same energy that Earth takes from the Sun. That is why scientists keep hoping that liquid water may exist on the surface of Proxima B, like the water oceans on Earth. If liquid water is discovered on this planet, it reveals that life may exist in Proxima B. A solid reason for life's existence on our planet is its controlled atmosphere by absorbing the X-rays. X-ray photons are tiny, high-energy packets of electromagnetic radiation absorbed by meeting with isolated atoms. The thickness of the atmosphere is vast, and the quantity of the atoms is massive, so an X-ray photon passing through the atmosphere will confront as many atoms as it would in passing through a 5-meter thick wall of concrete. Our Earth absorbs these high-energy molecules that pass through its thick atmosphere. The thick and robust defensive atmosphere keeps life safe and secure from these X-rays like the Earth. Without this defensive atmosphere, life cannot exist on any planet. A strong example of this unprotected atmosphere is Mars. Mars is a planet where life existed billions of years ago, but because of its undefensive atmosphere, life went extinct. Therefore, Proxima B does not have a very strong atmosphere, and it releases a massive amount of X-rays, occasionally up to 40,000 times the Sun's release. That is the reason that compels us to create the hypothesis that if life could have existed here, it may be extinct. This red dwarf planet always faces the same side of its star, which means the day and night are the same in its locations. A few parts of the planet are always plunged into darkness, which means it always has night, and the other side has a light that remains the same without changing. Because of this, the light side would always be dry, and the dark side may have icy water or glaciers. This sign indicates the likelihood of life because it shows that the cold side of the planet may have a chance of existing by inducing humid environmental conditions. The delightful thing about this tidally locked planet is that it has a side-face light reaching a boiling point and constantly produces cyclones. It shows there is just a small region in the Proxima B where life can exist. Now the question is whether the defensive atmosphere is enough for life to exist on any planet or something more. The answer is that the protective atmosphere is not enough to prove the life savings on the planet since it just saves life from the fatal X-rays, but it should have life-nurturing elements like oxygen. However, Proxima B is very close to its star, so it may have a scarcity of oxygen and nitrogen, which are essential for life. Astrophysicist Ed Turner of Princeton University said there's no guarantee having a solid atmosphere means the existence of life. Proxima B may be like Venus, which has a 90 times thicker atmosphere than ours. Now is the time to talk about the James Webb Telescope. The primary purpose of launching the James Webb Telescope is to find life beyond our solar system. Previously, scientists have tried to find life in our solar system, especially on Mars. However, Mars proved as a dead planet, and its atmosphere is not suitable for life's existence. Though billions of years ago, life may have existed here, it is now a deceased planet. So the scientists launched a giant telescope named James Webb Telescope. The successor of the Hubble Space Telescope came to drive the cause ahead of the heritage of the Hubble Space Telescope. It works to keep an eye on exoplanets and investigate the crimes of our neighboring star. It was designed primarily to conduct infrared astronomy, but because of its investigation skills, it got a promotion and put up with the designation to observe objects early, distant, or which are not possible for view for its predecessor. Scientists believe it will not disappoint them and bring good results in cosmology and astrology. For example, it will be able to observe the first star, the formation of the first galaxies, and detailed atmospheric depictions of potentially habitable exoplanets. The James Webb Telescope launched on December 25, 2021, an Ariane 5 from Kourou, French Guiana. Furthermore, it arrived at its destination at our Sun L2 Lagrange point in January 2022. It started its work by reaching the destination, like a good employee, and released its first image to the public on the 11th of July 2022. The James Webb Space Telescope is 6 times stronger and more efficient than the Hubble telescope. Hubble was observing near ultraviolet and infrared, but the James Webb Telescope was examined in a lower frequency range, from long wavelength visible light to mid-infrared. The telescope has the power to live in freezing weather below 50 K. Similarly, it is deployed in a solar orbit near Earth's Sun L2 Lagrange points, about 1.5 million kilometers from Earth, where its sunshield protects it from the warming by the Sun, Earth, and Moon. James Webb Space Telescope has a mass that is about half of that of the Hubble Space Telescope. It has more excellent skills than its predecessor Hubble, since it can see orange and red visible light and the mid-infrared region. It can detect 100 times fainter objects than Hubble, but its greatest talent is for observing the earliest objects in the universe's history, at the time of the Big Bang, earlier stars, and the first galaxies. One of the primary purposes of bringing this massive telescope into the world is to investigate the formation of galaxies and stars, to find how and when the first star was created. The ground-based telescope must look through the Earth's atmosphere. The Earth's atmosphere is murky in many infrared groups, even where the atmosphere is transparent. Since the chemical compounds water, carbon dioxide, and methane are also contained in the Earth's atmosphere, these telescopes could not observe these groups because their mirror was so frigid, which signifies that the telescope illuminates forcefully in the relevant infrared groups. James Webb Telescope can also observe the solar system at a curve of more than 85 degrees from the Sun, and has a probable angular motion of less than 0.03 arcseconds per second. The Webb Telescope has 4 main crucial goals: inquiring about light from the first star and galaxies that cropped up in the universe after the Big Bang, the evolution of the galaxies, examining stars and planets' formation, and investigating the planetary system and ancestry of life. To complete these goals, the James Webb Telescope was necessary. Initially, James Webb Space Telescope was used for gathering information on the dimming light of a star, which was discovered in 2015, and has unusual light tangle properties. After this, it showed an exoplanet had methane in its atmosphere, which compelled the astronomers to figure that methane may be a sign of life. The primary hint of intelligent life on Proxima B was found in 2019 when scientists received the signals from a Parkes radio telescope in Australia. Signals have been coming in 30-minute intervals for several days from the Exoplanet Proxima B. This data compelled us to figure that if the signals came from an extraterrestrial creature, then should we reply to them or not, since it could be dangerous for the survival of humanity? The main goal of modern astronomy and planetary science is to discover life outside of Earth. Life may exist where there is liquid water. Scientists found traces of icy water on Mars, but because of its atmosphere, it significantly reduces the chances that life would exist on this planet. Therefore, astronomers decided to find it beyond our solar system, when they did not find any clue of life in our solar system. There are 300 habitable planets in the Milky Way galaxy alone, and various habitable Earth-sized planets just 30 light-years away from Earth, and astronomers have discovered 5,000 exoplanets. So to observe life on distant planets, astrobiologists studied the starlight interacting with the planet's atmosphere. If the atmosphere was adapted by life, the light carries a signal called a biosignature. For this purpose, they needed the James Webb Space Telescope that could observe distant planets and stars and detect these signals from an exoplanet, since the ground Webb telescopes like Hubble cannot detect these signals in fainted elements in an exoplanet atmosphere. For this goal, we needed the James Webb Telescope. James Webb Telescope detects biosignatures by studying planets when they pass in front of their host stars and capturing starlight that filters through the planet's atmosphere. If you like this video and want to watch more exciting and informative videos, subscribe to the channel and hit the bell icon.